Hello everyone. Hope I am able to you are able to hear me. Am I
Yes, sir.
audible now? Yes. So if you have any queries, you can ask with us. Like in fact, you can ask your query in the chat box also. We will discuss accordingly. Or if you have any challenges with any lecture or any doubts with respect to the lectures or any assignments, okay, or anything you would like to discuss regarding the question paper, whatever it may be, the doubts or queries you can ask with us. Hello, am I audible now? Hello.
Yes, you are audible, sir.
Okay. I think someone is messaging that they are not able to hear us. Sir, it is in which lecture, sir? Lecture number? So someone is asked that in MMF distribution of AC machine lecture at 30-35 seconds, the sum of cosines I am getting so on. So I think I need the lecture number at least to clarify it. This question, a question asked in the Google form. PS, you know which lecture it is? Monica and Sagar. You have any?
MMF lecture is 19th lecture, sir.
19th lecture. Okay, let me check. Is there anything like sum of cosines I am getting sine into cos QNB divided by? Yes, assignment solved answers, you will get it soon. Maybe as per the terms and conditions given by the NPTEL office, we will upload the answers accordingly for each and every assignment. Monica, can you check backend like at lecture 19, 30, 35, what is the like what is going on exactly?
Yes, sir, I am checking.
Okay, exactly at 30 minutes, 35 seconds, then you can give the clarification.
Yes, sir.
Apart from this, any other queries? Abhijit, someone RR.RD, then Pradeep, Pavitra,
Hello, sir. This is Abhitej speaking. It's audible?
Yes, Abhitej.
Yeah. So basically, for all the assignment questions, do we also get any similar kind of concepts getting solved by any of your students? Last time when I joined for induction motors,
Yeah.
there was one student who was helping us solving the answers with a different framework of questions, but the concept remains same.
Okay.
Will this kind of thing will happen so that it will be helpful to solve the assignment problems.
Okay, you are asking some tutorial kind of thing, like
Correct. Yeah.
yeah, if requires, we can give the additional questions to
Yeah.
the all learners and
Yeah.
with answers before submit, like similar to the assignments or slightly
Correct.
different the assignment. So you
Correct, sir.
require before assignment or after assignment?
Before assignment will be helpful. Like on Saturdays or any day is fine. Like
Okay.
evening or sometime if they can
Okay.
take the session similar questions and help us out solving. So we will learn the concept, and then
Okay.
by before Wednesday we will be able to solve
Submit.
our assignments and
Okay.
submit. That will be very
Okay.
helpful.
Okay. So okay, then we will arrange either sessions or some practice questions with like example questions we can share
Correct.
with you people. That will be fine for you.
Yeah, yes, sir. That will be really helpful.
Yeah, sure. Then we will share at least 5 to 10 questions, some practice questions also. Based
Correct.
on that, you can solve for your assignments.
Yeah, yeah, sure, sir. Will
Okay.
this be posted in the announcements or Q&A, or
Yes,
will
yes. It
you?
will be posted on the official website.
Okay, sir. Okay.
Okay.
Thank you.
So, okay, Abhitesh. And some question from the Google forum. We received that. Can you please explain regarding the slots per pole combination decided for the various type of motors? Okay. See, generally slots per pole combination is depends upon how many number of slots we are taking and how many number of phases and how many number of poles we are taking. Based on that, we can decide it. Just let me share my screen with. Hello, hello, sir. Gurraj, sir.
Yes,
Hello.
sir. Yes, sir.
Sir, I am trying to share the screen from the other screen. It's not coming actually.
No, you are the co-host, sir. You can share.
Mhm.
Other means,
One more, like one more user, I have
yes, both
started.
we are giving permission, sir.
Option. One. One minute, sir. I'm just trying to log in again and then. It looks like it is not coming, sir. I'm sharing the screen.
It is now the whiteboard is
Yeah.
coming, sir.
Yes, sir. Now it is fine.
Okay.
Okay. So the basic equation slots Q is equals to M into P into Q. Here M represents the number of phases, P represents the number of poles, and Q represents the slots per pole per phase. So this Q, the number of slots per with respect to the stator core will be decided depends upon the power rating and how much magnetic loading required and how much torque required. Basically, in detail explanation I have covered in the week 5 or week 6 lectures where we are discussing the design of induction motor. But here, for the winding design, just we have to take as per the standards either 36 slots. So are 72 slots. 24 depends upon the standards, either 24 slots, 48 slots, 36 slots, okay, or 18 slots. It will be multiples with respect to the how many phases we have, and then 54, so and so on. So let us take an example. 3-phase motor is there and 4-pole. The slots per pole per phase will be, if 36 slots are selected, 36 with respect to the 3-phase and 4-pole, it will be slots per pole per phase, it is coming 3. Same way, if it is 2-pole combination, slots per pole per phase will vary accordingly. So this Q will come 36 divided by 3-phase into 2-pole. So it will come 6 slots per pole per phase. So we have to select, depends upon how many slots we have on the stator core, and then how many phases we are considering with respect to the stator winding. So based on that, we can calculate the slots per pole combination. Sir, apart from this, any other questions, sir, from the Google forum?
No, sir, that's it.
Okay. Assignment 4, question number 3 and 4. Okay, let me open assignment 4. Monica, this assignment 4 deadline is over, right?
No, sir. Tomorrow is the deadline.
Okay. So let me see the questions. At least I can give the hint, Abhitej. So because after the deadline, I can explain the answers clearly. In your case, let me check the, okay, third and fourth question. Okay, I will take the similar question, not the same question. So here, this is with respect to the finding the which of the following flux plot will be correct, right? With respect to the different instance. Okay, if I'll explain one instant, is it be fine for you, Abhitesh? Same question I will take.
Yeah, sure, sir.
So I'm taking the same question. Okay, the question is given is two coils A dash, B dash are placed mechanically 0 degrees and 90 degrees respectively. That means first coil is placed here. That is A is here and A dash is here. And the reference is given with respect to this particular one. Here, this is the reference axis is given X. And the second coil is B dash, that is placed 90 degrees mechanically. This is B and this is B dash. And these coils are excited with a current of A sin omega t and A sin omega t plus 60 degrees. A dash is excited with A sin omega t and B dash is excited with A sin omega t plus 60 degrees. Then which of the following shows the correct flux plot with respect to the instant omega t is equals to 0 degrees, 90 degrees, 180 degrees and 270 degrees. Correct, right? So here I'll explain with respect to the 0 degrees. You just solve the remaining things, then you will get the answer.
Yeah, sure.
Since the deadline is not over, so I can't explain everything. So, but definitely after the deadline, you can come back to us. TS will explain in detail. Okay. So here, take these are the currents, right? So at omega t is equals to 0 degrees. If I'll substitute omega t equals to 0 here, what is the current value for A dash? I dash equals to 0. I B dash is equals to A sin 60. A sin 60 is nothing but root 3 by 2. That is positive current, right? So simply you just remember whether it is positive current or negative current. Once you know if A dash coil has 0 current, B dash coil has the positive current, then you just represent with cross and dot polarities here. So with respect to the B, it is positive here. So here cross and here it is dot. Okay. So with respect to the clockwise flux lines, the cross will be clockwise flux lines and dot will be anti-clockwise flux lines. So the resultant flux vector will come in this direction. Okay, at omega t is equals to 0 degrees. Is it fine? So same way you can do it for the remaining cases. But here in the answers, that omega t is equals to 0 degrees. Yeah, is it fine, Abhitesh? This is the omega t equals to 0 degrees explanation. Same way you can do it for the remaining cases.
Sure. Okay.
Is it, for example, if 90 degrees is there, one
Yeah.
more instant also I can solve.
Yeah.
If 90 degrees is there, sine 90 will become what? 1, right?
1.
So it
Yeah.
will become 1. So still positive current is there for one A dash coil. So for 90 plus 160 is 60, it will be 150 degrees. Sine 150 degrees will be second quadrant. Still it will be positive, right?
Correct.
Okay. So then you can see the vector direction. This is phi B and phi A will be here. Here cross and here dot. Cross
Okay.
will be clockwise flux lines and dot will be anti-clockwise flux lines. This is phi A
Mhm.
and this is phi B.
Okay.
So the resultant you can calculate phi A is equals to A sine 90.
Mhm.
Okay. And phi B is equals to, or instead of A you can take phi M, because in the answers we have represented phi M as a magnitude.
Yeah.
Phi M sine 90. Phi B is nothing but phi M sine 150 degrees. So the resultant vector magnitude will be phi R is equals to square root of phi A square plus 5b square. So it will be 5m square, it will come for the first term. The second term will be sine 150 will be 180 minus 30 I can take. Sine 30 it will be 5m into 1 by 2 square. 5m square into 1 by 2 square. Correct, right?
Correct.
So the answer will be 1 plus 1 by 4. It will be 5 by 4.
Yeah.
So 5 by 4, 5m. 5 by 4 should be square root. So at 90 degrees, the magnitude will be this one. Square root of 5 by 4. Or I can write with respect to the answers, square root of 5 divided by 2 into 5m. And the resultant will be, these are the resultant will go here, right?
Correct.
The resultant of 5a plus 5b. So it will be in the second quadrant, and the magnitude with respect to the second instant will be square root of 5 by 2. Is it
Okay.
clear?
Yeah, it's clear, sir. Yeah.
So same way you can do it for
Yeah,
the
for
remaining
other
two instants in the
instances.
third question. And
Yeah.
the fourth question, let me check. The fourth question is the same question, but it is a three-phase thing. Like 3 coils are given, mechanically displaced by 0 degree, 90 degrees, and 210 degrees.
Okay.
In shown in figure so and so, and then let me share the question if required.
Got it, sir. Instead of 2, they have made 3 coils,
Yes,
and
instead of
accordingly,
making-
I have to replace 0,
Yes,
90, 180,
yes,
and then
yes.
find out the resultant out of
Resultant vector, and then direction also you can find. Like addition of 3 vectors, how you can do in math.
Sure, sir. Understood. Got it.
Okay. Otherwise, you can do simply, you have 3 vectors, right? Assume that you are getting 3 vectors in this fashion.
Mhm.
This is phi A, you assume it. Let us say phi B is coming here.
Mhm.
I am just taking randomly. These 3 vectors, I have to add it.
Mhm.
Okay. So I can do phi A plus phi B plus phi C. Vector sum should be equals to your resultant vector. So
Mhm.
first I can calculate these two vectors phi A B sum
Mhm.
plus phi C. Okay,
Okay.
whatever you are doing for 2 coils, same method you can follow for to find the phi AB.
Okay.
And once you know the resultant of phi AB, then you can again add phi AB with the phi C.
I see. Okay. Understood.
Then you will get the resultant. Otherwise,
Yeah.
simply you do the vector addition of 3 vectors like phi A at an angle 0 plus phi B at an angle, some whatever it may be the angle, generally 120 phase shifted, right?
Yeah.
Phi C at an angle 240 degrees is equals to your phi R. And then here phi A is nothing but phi M sin omega t. Phi B is nothing but phi M sin whatever the excitations they have given in the question. Phi M
Understood.
sin omega t minus 120. Phi C is nothing but phi M sin omega t minus 240 degrees. You just substitute those numbers. You will get the magnitude as well as the phase. Phase will be tan inverse of imaginary part
B
divided
by
by B by A, and magnitude will be square root of all terms. A square, first term plus second term plus third term square. That's it.
Okay, sir. Understood.
Okay. If you have any doubt, you can come back to us. Like you can
Yeah.
send a mail to me or you can send a mail to TS. They
Okay.
will respond to your question.
Yeah. So your mail ID is mentioned here only, right?
Which one?
Your mail ID.
Mail ID is bpratap@iiti.ac.in.
Okay.
If you have any queries, you can come back to me.
Sure, sir.
iiti.ac.in. I have
Yeah.
shared the mail ID in the chat box. You can check.
Understood. Yeah.
In fact, TS, can you share your mail IDs also, Monica and Sagar? Just share your mail IDs. If they have any
Yes,
doubts,
sir,
we will
share.
yeah, they will come back to you people.
Sure, sir. So like as I requested, if you could share that similar questions, it will be very helpful, sir. Yeah.
Yeah, definitely we'll look into that, and maybe next week onwards. Let us say this week, which assignment is going on now?
Now, week 4 is tomorrow last day. Week
Deadline.
5 will be 27th. So
Okay.
if you could,
So at least for week 5 onwards, we'll give
yeah,
some questions for practice.
correct.
Okay, but don't expect that same kind of questions may come,
No,
but
it's only for
similarity will
concept
be there. That's
understanding. Yeah, it's
uh,
only for concept understanding. That will
yes,
be
yes.
helpful.
Yeah, that will be fine. We'll share at least 5 to 10 questions every week
Yeah,
for practice. Yeah.
yes, sir. So by 23rd Saturday, if you could share similar questions of week 5, so we could practice and we can submit our assignments before 27th.
Okay, okay. Yeah,
Thank you.
definitely we'll update in the NPTEL portal itself.
Okay, sir.
As a practice questions we'll upload, then you can
Yeah.
check those things.
Sure, sir. Thank you so much.
And one more question in the chart box is mentioned that what are the parameters mainly considered while selecting the magnets for motor design? Okay, see, magnet generally, as I mentioned in the basic realization of electrical machines, to realize any machine, we require two magnetic fields. Okay, so how we are creating these two magnetic fields will differ. Okay, either one can then realize the machine with both sides electromagnets, for example, DC machine and induction motor. And one can realize one side electromagnet, one side permanent magnet, either BLDC motor or PMSM motor. So here your torque is directly related to the flux contributed from the stator magnetic field as well as rotor magnetic field. So that I can say torque is directly proportional to your phi 1 and phi 2 or I1 and I2. Okay. So how much with respect to the permanent magnet, I can say one side you have the electromagnet, let us say phi 1 or I1, whatever it may be. Let me take this as a I1. I1 is the stator side with respect to the electromagnet, and phi m is the with respect to the magnet. So the amount of torque based on the amount of torque requirement, you have to select the magnetic permanent magnets with respect to the magnetic intensity and V value and how much flux it can contribute. Hello. Yeah. So that is the actual answer. How much torque you require, that much based on that you have to select the magnet density. So how much based upon the flux, you have to see the BH curve in the second quadrant, especially for permanent magnets. You will see the BH curve in the second quadrant, like this fashion. How much H value you have and how much B value you have for that particular magnet. Let us say neodymium magnet is there. So for that, different grades will be there in each and every magnetic material. So depends upon the B value and H value requirement, we will get the required flux. That required flux should be responsible to deliver the required torque. So based on that, we can select. And any other question? Okay.
So just one clarification. So with reference to B and H value, will this also influence the motor temperature by any chance? Like,
Yes, yes, definitely. Because you have to keep it in mind that your core loss and then your magnet or iron, whatever the iron you are utilizing at the stator side. Let us
okay.
take that you are using here very powerful magnet, which is generating 2 Tesla or whatever it may be. Let us say some
Yeah,
2,
N40 or N42.
yeah, very high density magnet I am using. But
Okay.
stator side, I am using the normal
Copper
steel.
winding. Yeah.
Yeah, copper windings and normal steel I am using, which has the capability of flux will be, let us say, 1 Tesla.
Mhm.
Rotor side, it is able to give the 2 Tesla value, but stator side, I am keeping 1 Tesla. That means stator side core may saturate, right? It
Yeah,
will be
correct.
heated. Because always whatever the flux is generated by the rotor, which will be interacted with the stator cores, and stator flux will be interacted with the rotor core. The attraction of these two magnetic fields are creating force or torque in your electrical machine.
Okay.
So you have to select precisely such that your core saturation should not happen.
Okay. We are not able to hear you, sir. Hello.
Hello, am I audible now? Sorry, some network.
Yes, sir.
Yeah.
You're audible.
So apart from these queries, any other queries or doubts?
Sir, I have posted another question regarding MMF distribution, sir.
Can you repost it again, because the moment I exited, the chat box is empty.
Okay, sir, I will do it now.
Okay. Yeah, MMF distribution of AC machine, week 4. Which lecture in week 4? It is 19th lecture only.
Yes, sir. It is 19th lecture.
Okay. And exactly at 30:45, what is happening, Monica? Have you verified?
Sir, in that question, you have derivated the MMF waveform.
Okay.
So in that, the learner is asking that he is getting cos n beta in place of cos n beta by 2. So I will share the solution
Okay.
by the mail.
Okay. Okay, Ashwin, I think TS will give the detailed derivation and share with you. I think you can drop your email ID in the chat box. Okay.
Okay, sir.
Or you send a mail to us, then we will respond to that particular mail, detailed derivation. It will come actually, because during the lecture, we won't get that much time to cover different contents. So that's why I have given first steps and then last step. I think that MMF equation for distributed winding, right? You are asking.
Yes, sir.
N beta by 2 is coming, means it is a distributed winding. So actually that answer is correct. We will show that detailed answer for you. Okay.
Yes, sir. I will share the detailed answer, and if the learner want to refer, then in LiPo book it is written how to solve.
Okay.
So he can refer that book also.
Okay.
Book page number 59, 2.3 distributed winding section. Hello.
Yeah, I think learner. I think
Yes,
hope
sir,
you
I
are.
got it.
Yes.
Yes.
And one more thing, I think some learner is asking what is the standard grade for EVs with respect to the magnet. Yeah, actually, exactly which grade and what is the B value and H value, it is difficult to identify. Let us say Tesla motors, like Tesla, all Tesla vehicles are using one PM assisted synchronous reluctance machine and induction motor. And let us say Tata Nexon is there. Tata Nexon is using PMSM motor. But which grade and which type of magnet they are using also they won't disclose on the public domain, because they are, those things are their IP rights. Okay. Ideally, neodymium magnets or samarium type of magnets we are using as a permanent magnet site. But exactly which grade, it is tough to identify. But I can give one website that is 1 minute. Let me check. There, I think who is working in the industry domain, they can get it. They can see if there are any like tear down videos or tear down data is there. Like some people used to open the complete electric vehicle and they will show which type of magnets are there, which type of batteries are there. Okay. For example, Tata vehicles, I know Munro, one person is there who is used to tear down the all vehicles, and he used to show the different parts of the electric vehicle. 1 minute, I will show one example. Yeah. So I am sharing my screen. You can see. So are you able to see my screen?
Yes, sir. It is visible.
Yeah. So I have opened some Munro live teardown for Tesla vehicles. Okay. So are you able to see the links, whatever I'm showing here? I think YouTube screen. Are you
Yes,
able
sir. Yes, sir.
So you can see here Tesla Cybertruck, they are opening completely and they are showing some videos. Same way for different things. Okay, Tesla Model 3 tear down video is here. So in this kind of videos, if you will identify for permanent magnet based EV vehicles, then you may get some information. Otherwise, since that are their IP rights, they won't disclose in detail. Yeah, magnet grade definitely depends upon the power rating. And N38 grade, yeah, maybe true, because I also didn't gone through it exactly which grade they are using for two-wheelers and then four-wheelers exactly. So if anyone is using specific, like anyone is working specifically for motor designs in industries, they may give some detailed information. Okay. Otherwise, it is tough. It is tough to get which grade we would like to use in the EV. Okay. Apart from this, any other questions?
Sir, can you solve the assignment one first question, sir? I have some doubt in that.
Assignment one, first question. 1 minute. Let me open. Yeah, assignment one. Consider the two identical metal spheres having the same electrical charges repelling each other with a force of 4 into 10 power minus 5 Newton. The third identical sphere, C initially uncharged, and it is brought in contact with the sphere. After contact, what will be the resulting charge ratio between A and C? See, you are like it is straightforward, right? You have the like two identical charges, A and B, are repelling each other with the force of 4 Newton, 4 into 10 power minus 5 Newton. Okay. Identical charges means you assume that A and B have the same charge. The moment if you will bring any uncharged particle or uncharged sphere in contact with A, definitely charge equalization will happen, right? Assume that simple capacitor is there. You have fully charged capacitor. You are connecting another capacitor which doesn't have any charge, and you are connecting in parallel to that particular capacitor. What it will happen? Definitely charge equalization will happen, right? Half up. So here also same story will happen. If you want to prove with respect to the Coulomb's law, you can prove. Okay.
Actually, I got it, sir. But the problem is, if a charge equalization happens, the ratio of charge between A and C should be 1, right, sir?
The resulting charge ratio after contacting. Yes, the ratio we are asking.
But the answer was 0.5, so that's my confusion.
Okay, I think this question after contact, what will be the resulting charge ratio between? Yeah, it will be 1 only. So
Okay.
if charge is shared by both spheres now have the charges q by 2, q by 2, then the ratio should be 1. Yeah, we will remove that question. Okay, here I can see the answer they kept 0.5.
Yeah, sir. That's
Since the question they have mentioned ratio, it should be 1. Yeah, definitely we will remove that question and we will evaluate first assignment for question number 1. Sorry, 9 marks only.
okay.
TS, can you note it down, the first question? Option should be B, but somehow
Yes, sir.
there
Yes,
is
sir,
a
definitely.
typo in 0.5 is mentioned.
Yes, sir.
Okay. So definitely we will remove that question and then we will evaluate that particular assignment for 9 marks only.
Okay, sir. Thanks.
Okay. And TS, I think in between some assignments, some typo mistakes were there and you have updated the question, whether the learners are able to see that changes or not. I think in assignment 2 or assignment 3.
In assignment 2, we have shared the files, sir. What
Okay.
the correction is required, and we have
Okay.
shared the mail to all the learners also.
Okay. So hope you have received those changes, right? I think learners while solving the assignments. I think assignment 2, question number 6 and question number 7.
Uh,
I think assignment 2 deadline is over, right?
Yes, sir.
yes, sir.
Okay, let me share it then. So are you able to see my screen?
Yes, sir.
Yeah, so here one typo was there in the image, especially in the whatever it is in the text, it was correct. But in the image, it was mentioned some other number. But now we have rectified here, and then we have shared to all learners who have registered for this course. Hope you have received this changes file.
Is it posted in Q&A or in announcements?
In announcement, we have shared.
Ah,
So in announcement, you might get that the figure and the questions are mismatching. So we have mentioned that in figure it is 6 centimeter, but it should be 6 mm.
which date you have uploaded?
Date is first,
But
1st
when is
August.
Ah,
Hello?
yeah, sure. 1st August, right?
if you have any issues with these questions, you just let us know. Okay. Because we have updated immediately. Hope you have got the updated file.
For me, in announcement, I see that week 3 content is live now. After that, the next post is on 8th August. Maybe others can also.
Okay, in the mail you might have got, right? I think to everyone we might have sent an email.
Okay.
Okay. Apart from this, any other queries you have?
You can search clarification on second assignment. We have shared on 1st August the mail to everyone. And the deadline was 8th August for second assignment.
Okay, sure.
Gururaj sir?
Yes, sir.
Sir, is there any other questions in the Google form, sir? Google forum?
No, sir, there are no questions.
Okay, sir. Then can we conclude, sir, here?
Yeah, sir, if there are no questions, we can conclude, sir.
Okay, sir. Then. Thank you all for joining the session.
Thank you.
If
Thank
you
you.
have any questions, you can get back to us at any time, like either to me or to the TS.
Sure, sir. Thank you.
Okay, thank you.
Yes,
Sir?
sir. Thank you all.
Hello.
Hello, sir.
Yes.
For any doubts, should we directly mail you or any other way for clarification, sir?
Like first you contact to the TS. If you still your doubt is not clarified, you can come back to me. Otherwise, you can send a mail to me also. Like you have some forum, right?
Yes, sir.
Like
It
for
is.
all learners, one forum is there. You can send a mail to NPTEL. I think one email
No,
ID.
so they can use question and answer section.
Yes, sir.
Okay,
In
okay.
question and answer section, one discussion forum is there. So then
Okay.
they can share their question there, and we will answer them.
Okay. Thank you.
Still, if you have any doubt or anything, it is not convincing for you people through the forums conducted by TS, you can come back to us always.
Okay, sir. Thank you.
Okay, sir.